Are we ready? Can we start?
Yes.
Okay. Welcome to this online lesson. My name is Teacher Ashaba Fredrick. Today, we are going to look at how to deal with discrete random variables. So how many of us have so far covered the discrete by show of hand or by tick? Those who covered it at school? Those who had covered the probability, the beginning part, introduction? None. Esther back. So Esther, what is in probability? And yes, Dorothy. Somebody to give us a brief of probability. Rachel. Yes, Esther. You can tell us some basics in probability.
In probability, we learned that it is the measure of the chance of an event occurring or not occurring. We have probability laws, there's a contingency table, and then we have different events in which these probabilities can occur. We have independent
Yes.
events, we have mutually exclusive events where they do not occur together. The independent events is where the probability of one event occurring does not depend on that, does not
Yes.
affect the occurrence of the other. And then
Yes.
we had various examples. Then we have conditional probability, where the probability of an event occurring has to be on condition that also occurs. Let me say the probability of A given B, it has to be that the probability of the intersection over the probability of B occurring. So we have very many examples, but we can get them mostly from the question bank and from the textbooks. Then we study tree diagrams where I can give an example of maybe a question in the question bank where they tell us that there is a bag that has two colors of balls in it. So that what's the probability that you're picking red when you pick the first time, probability that you pick red and not blue, or you pick blue and not red, and it depends on how many times you're picking from the bag. So probability just keeps on going like that in tree form. Your diagram is in the tree form. That's how I can summarize it.
Okay, thank you very much. Any other to give us a brief of probability? So today we are I had prepared this hoping that most of you had covered probability, but nonetheless we shall cover it. So discrete random variables fall under probability density function. And as all of us know what a function is, a function is where every element in the domain has only and only one element in the range. So likewise, here we are going to have our probability values being mapped onto other values in the range. So that means, but putting in mind that our probability only lies between 0 and 1. So that is what we shall put in mind. And then, like as in statistics, in this probability density function, we shall find mean and what we shall always call expectation. We shall find variance. We shall find mode. And those ones will be the specific one. And of course, we shall find the probability values. Then these probability density functions are divided into two. So we have discrete random variables, and these ones deal with countable domain. So their range is given in terms of 1, 2, 3, 4. So for them, they are countable. Then we have the continuous random variables, and that one deals with intervals. For example, if they tell us between 1 and 4, so that one is in discrete, and that one has its own way of how we handle it. But for today, let us focus on discrete random variables. So we are beginning with properties of a discrete random variable. So remember, I've told you with discrete, we are dealing with the countable domain. So those the numbers given to us are countable, so we can distinguish them. So we are saying if x is a random variable, then summation of probability of x equaling to small x. So summation of this probability here is equal to 1 because we said our probability values lie between 0 and 1. So if we sum up all the probabilities, they should be able to give us 1. Then another one, probability of x equaling to a small x should be greater than 0. So the smallest value of the probability should be 0. So with these two properties here, we shall be able to solve some few problems that involve finding constants and also finding probabilities. So we have an example that we are beginning with, which Esther had somehow briefed about, that given that a coin is thrown 3 times, and x is the number of heads that are obtained. So we can now work out this and then transfer it into a probability density function, which is discrete. So when we begin, we have only 2 possibilities of a coin. Our coin has only a head and tail. So meaning when you toss it, it has options of showing a head or a tail. So when we toss our coin, what will be the probability of getting a head or a coin, of getting a head or a tail? Very quick answers. What will be the probability of getting a head or a tail? Yes, Arthur?
A half.
A half. Tumusime.
A half.
Okay.
A half.
Okay. So the answer will be a half. So the probability of getting a head or a tail will be a half. But our coin here is tossed 3 times. So therefore we are going to have 3 appearances. So this is the first one. So this is the first. So where we have, we can either pick a head or a tail, and their probabilities will be a half. Then when we go to the second one, if on the first toss we had got a head, if we toss again, if we pick that coin and toss it again, we still have 2 options of getting a head or a tail. If on the first toss we had a tail, we have options of getting a head or a tail. So if this process is continued, we shall have our tree diagram look like this. Are there some people with some questions before I proceed? Okay, if there are no questions, then we can continue. Now, we said a probability of getting a head is a half. So meaning everywhere will be a half. A tail is also a half. So this is a half. So here the probability of getting a head and another head will be equal to a half times a half and times a half. And this gives us 1 divided by 8. So it will be the same. So this 1/8 will be the same for this, for all these probabilities, since all of them are a half. But we would identify, because our interest was to get the number where we only have the heads. So where we have 3 heads, where we have 1 head, where we have 2 heads. So remember, we only have 3 tosses, so meaning our sample space only goes up to a 3. Then for some of us who haven't covered probability, we didn't talk about the sample space. So a sample space is the expected outcomes, or the outcomes after performing an experiment. So like here, if we wrote out all these possible outcomes, we would come up with a sample space. Then an event is those desirable outcomes. For example, if our interest is to get only heads, so head would be our event, because that is our area of concern. So here our probabilities at the end would give us, yes please. So we can continue. So we have seen, so we can list these ones here, much as I've made the other one look dirty. But we could list the outcomes. So here we shall have head, head, and head. So I've done, so this first one, the second one, the third. Then first, second, third. So here you would have head, head, and tail. Who can give us the next? You just unmute your microphone and speak.
It's head, tail, and head.
Head, tail, and head. Yes, next one.
Head, tail, tail.
Head, tail, tail.
They are over for the head.
Sure. The heads are over. So we come back here. So we begin with T, H, and H. So it is tail, head, and head. Then here we shall have, yes, Kevin?
Head, tail, head, tail.
Tail, head, tail. Another one.
Tail, tail and head.
Tail.
Tail.
Okay, okay. So it is tail, tail, and head. And then lastly,
Tail, tail,
Tail, tail, tail.
and we saw that all these after multiplying, they give us 1 divided by 8. So can we identify where we have one head? We add up those probabilities. Where we have 2 heads, we also add up those probabilities, and where we have 3 heads before we move to our next slide.
Pardon, sir. Not getting you.
For example, our interest was to get
Master's network again.
So am I clear? Then like where we have one head, we now come and check and identify where we have one head. So for example here, it's one head, tail, head. We only have also one head. Then we have another one head here where we have tail. Okay, head, tail. So these ones all are 1/3, 1/3. So when we add them, they give us 3/8. Then we go and check where we have 2 heads. So this is the 2 heads, the 2 heads, and the 2 heads. Theirs is also 3/8. over 8. Then lastly, where we have all of them being heads would be 1 over 8. Is that understood?
No?
It is not. Oh, wow. Okay. What would be the probability of of getting all heads, all the 3 being heads? What would be the probability?
1 out of 8.
1 out of 8. Okay. So what you are not understanding, is it the table or the tree diagram?
How you're getting the 2, the 3 out of 8.
Yeah, that. Okay. Now, for example, for getting 2, the probability of 2 heads. Okay. So we have head, tail, which is 1 over 8. So we shall add it to head, tail, head, which is also 1 over 8. And we add tail, head, which is also 1 divided by 8. So when we add these ones, because of the same LCM, we shall have 3 divided by the 8. So is it now okay?
It is okay. That means you're only considering where there is only heads, right?
Yes, where they don't. So I'm considering where I have 0 heads because I can get 0 heads. Where I have 1 head, where I have 2 heads, or where I have all of them being heads.
Okay, got 10.
Okay, thank you. So we can now proceed to the table. So, but before the table, this would be our sample space, which we had said. When you write all the possible outcomes, and then we are letting X to represent heads. So like I had said, probability of getting X equaling to 0. So this smaller x is the one equaling to 0 would be 1 over 8, or where that is where we have tail, and tail. And it's then probability of X equaling to 1, where we have one head, would be 3 over 8. Let me get where there is one head, one head. One head. So those would be 3, and that would be 3 over 8. Then probability of getting 2 heads would be 3 over 8, as they have picked them from the sample space. Then probability of getting all of them being heads, which is head, would be 1 over 8. So now with the discrete, it is better for us to have all this information. This here, this one is here in table form to be tabulated for ease of other calculation. So we are saying the above information can be illustrated in a table form. Okay, so this is our table. We have X, which we said represents the number of heads. Then we have 0, where we have 0 heads, where we have 1 head, where we have 2 heads, where we have 3 heads. Then the probability, 1 over 8, 3 over 8, 3 over 8, and 1 over 8. And that is a simple way of getting this. But in most cases, it is given And in some cases, it is not given. They give you a question to like the one we have done, to perform an experiment, and then after make a discrete random variable. Any questions before I go to the mean? Any questions before we go to the mean? Yes, Rachel?
So like the way you've done for the head, it's the same way. If
Yes.
that ask about the tails, that's the same way we do, right?
Yes. Actually, as part of practice, you could do that. After
Okay.
the lesson, you could do that as part of practice. Any other? Okay. So when we go to the mean, for the mean here of a discrete random variable, we are saying the mean of a discrete random variable is sometimes called expectation and denoted by capital E in brackets X. And it is given by, so we sum up X, so we get X values, so which are here, these values here, and we multiply them by the probability values. So when we find their summation, when we add them up, and then that gives us the expectation or the mean of a discrete random variable. Then standard deviation and variance. So from statistics, yes, Elizabeth, do you have something to ask?
No, sir.
Okay. So from our statistics, how do we get standard deviation?
Sure, from statistics, standard variation is the square root of the variance, which
Is the square?
was the summation of fx over summation of f of v. That is,
So here our variance, yes. Okay, our variance is obtained by getting expectation of x squared minus expectation, which we said is the mean, then we square it. So this square is always there so this is the mean squared. So we get expectation of x squared minus the mean squared. And the expectation of x squared, so we get this x squared here, the small x squared, and multiply it by the probability values. And then after, we substitute in this formula and get the variance. Then after getting the variance, we just, if we are asked to find the standard deviation, we just find its positive square root. So we can conclude that variance is equal to summation of x squared times probability minus expectation of x. So this one should be squared minus x summation of probability times x squared. So this is the general formula for finding variance of a discrete random variable. So we have already said standard deviation is equal to positive square root of variance. So maybe we would go for an example here. So we are saying a random variable x has the following distribution. Probability of x equaling to 0 is equal to probability of x equaling to 1 and is equal to probability of x equaling to 0.1. I think there is some information. Yes, then probability of x equaling to 2 is equal to 0.2. Probability of x equaling to 3 is equal to probability of x equaling to 4, and that is 0.3. So we are told to find the mean and variance of x. So what we do first is to have this information in table form. So after having this information in table form, then we can go ahead to find the mean and the variance of x. So assuming that these other rows columns were not given, these ones here. So probability of x equaling to 0 and x equaling to 1 we are given as 0.1, 0.1. Then probability of x equaling to 2 is 0.2. And probability of x equaling to 3 and x equaling to 4 are all equal to 0.3. So we can first check whether when we add these probabilities here, they give us what? A 1. Because if they don't give us a 1, then it is not a probability density function. So 0.1 plus 0.1 gives us?
Recording in progress.
It gives us? Or are there people who have finished adding?
0.2.
0.2 plus 0.2?
0.4.
0.4.
Plus 0.3?
0.3.
Then plus another
0.7.
0.3?
0.2. One.
It's 1. Okay, 1.0.
That is 1.
Yeah,
Yes.
1.0.
Yes, so that would be, so we said for mean, to find the mean, we need expected summation. So to find mean,
Yeah, it's me who was trying to communicate those without audio. I see a number of them have joined without audio.
hey, thank you very much. Okay. Then the summation of x times probability values. So this is the formula for mean. So that means we'd have to get a 0 times 0.1, and that would give us what? 0. Are we there? Then we also get 1 times 0.1, and that gives us 0.1. Then 2 times 0.2, it gives us 0.4. Then 3 times 0.3 gives us 0.
Not find mean.
Yes? Any questions? So what we are trying to do, we are trying to find the mean. We said we get x, and then we multiply it by the probability values, and then after that we add. Then our last row was 4. Yes? Yes, please. Then lastly is a 4 times 0.3, and that gives us 1.2. So our expectation or mean would be when we add up all these values here, when we add up all so somebody can do the addition for us. Those who have calculators, yes, Dorothy.
2.6.
Yes. Others can type the answers in the chat. Yes, Lilian.
2.6.
And your hand is asked and you speak.
2.6.
2.6. Okay, thank you. Thank you. Then yes, I can say we are getting the value. Then for variance, we said our formula is expectation of x, so we get x squared minus the mean squared minus expectation of x, and we create a column for x squared times probability value. So we get a column for that, and it is here, so it is x squared times probability. We get 0 squared, which gives us 0 multiplied by 0.1 to still give us a 0. So 1 squared is 1, still gives us 1, 0.1, and 4 times 0.2 gives us 0.8. 3 squared is 9 times 0.3 gives us 2.7, and 4 squared is 16 times 0.3, it gives us 4.8. So we get this, so we add this one up, and when we add, what did we get? Yes, Rachel?
8.4.
8.4. Yes, 8.4. Lillian, what should we pardon? Got the mean, and this was the answer, which was 2. We said when, and 8.4 minus 2.6 squared. I think when you check with your calculator, it should be able to give you 1.64. We confirmed the 1.64 from our calculators. Okay. Maybe something simple here. If you have never given us your numbers and names, you can type them in the chat. There is somebody who is going to pick them up for easy follow-up. Previous lessons, please, you can type them. Then example 2, we have a random variable takes on integral values only and has a PDF defined by probability of x equaling to small x. So the function is f of k times x. So the value, and it also has probability of x equaling to small x, and the function is k into 10 minus x for values running from 6 up to 9. And then we are told to find part A, the value of the constant k, the expectation of x, and the variance of x. So how will our table look like? How is it going to be? Is that going to run from what value to what value? Okay, maybe because of time, let me do this and finish. Home. 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 Okay, bye. So our table will have values running 9.
In progress.
So what have we got as our K? 1/25 Tracy, Tipsy Fiki 1/25, Arthur 1/25, Rachel 1. Rachel, I think you made an error. Okay. 1/25 Rachel. Okay, thank you. So that is how that answer comes about. Then after that, we draw our table again and substitute for the value of K. So as you can see here, I'm creating another column and saying K is 1/25, 2K is 2/25, and the rest. So because of time, I might not go through all of it, but we had seen how to find expectation of X, which is the mean, and how these values come about. So you can still do that. So when we add this, it will give us the mean. And then when you add this and subtract the mean, it gives you the standard, it gives you the variance. So there are some questions. So if there are no questions, we can stop here. Thank you very much for your active participation. Briefly, let me talk about the Yaaka services. Our online